A fill line valve right here, located at the base of the channel. This is the head end of the chamber. The sluice gate that allows the water to enter the chamber is located right here, with it's operated directly above. The controls, the disconnect for that and the controls for that are located locally in the field here. And there is a valve here, which we'll take a look at when we get out there, for filling the tank, so that you're not taking a full load of wastewater head from, dropping it from this location down onto an empty tank and potentially doing some jarring of the grit collection system. So you can fill the tank using this valve here. The headers that feed the air into the system are located here. There's 4 headers per tank, there's 5 diffusers per header, 15 CFM per header. On the discharge end of the tank, this is that valve handle that I was speaking of, located here, looking downstream to the tail end of the tank. The launders are here, which allow the water to overflow from the grit chamber out into the effluent channel, which will take the flow off to the primaries. There is also an odorous air removal pipeline here, which is not in operation at this point in time. Eventually, these tanks will be covered, and the purpose for that is to remove the air from within the tanks to bring it off to your biofilter for destruction. The aerated grit tanks, as I said, 3 blowers, 600 CFM per blower, about 7 PSI on each one of the systems, 20 diffusers per tank, 15 CFM per diffuser, giving you the capability of running 1 blower per tank, 1 blower per side, east and west side with a spare blower. This is just a shot of the control panel for the blowers themselves. This one happens to be in operation. The temperature is somewhere around 120 degrees. You've got a high temperature cutoff for that. There's a pressure switch indicating what the pressure is coming off the system. That's been running at about 6 to 7 PSI, which is right in line with what the system is designed for. You've also got a magnehelic gauge here, which is looking at the differential pressure across your incoming filter. When that level begins to rise, that's an indication that your filter is becoming clogged, and you have to clean that filter.
What's the range on that?
I'm not sure what the scale is. I can check it when we get out in the field. I don't recall what the scale is. The air coming from the blowers is fed into the grit tanks through a couple of stainless steel lines. You've got an airflow monitor on each one of the lines. One goes off to the number 1 tank, one goes off to the number 2. That's fed back into the SCADA. Normally you'd be running about 300 CFM per chamber, so you can balance your flow if you've got 1 tank or 2 tanks online. You can use these gauges in order to check your flow rates. The grit collector itself, you've got 1 grit collector system per chamber. It's a coated chain with plastic buckets. You've seen that operation during the training. It's a timed operation whereby the system is operated based on the timer that you set into the system. Right now, I've got that set up for 15 minutes on, 15 minutes off time, and we can make some adjustments to that as we bring the system online. The buckets are washed as after the grit is dumped from them, and the discharge from the grit collector goes into the grit washer for organics removal. And again, this is interlocking to the downstream equipment, namely the grit washer. The grit washer itself is 1 per chamber. It's a shafted screw conveyor. There's a greasing mechanism on the bottom and the top of the screw itself, and this is interlocked with the grit belt conveyor downstream of it. Belt conveyor, very similar to the screenage conveyor, a little bit longer, same safety devices, belt alignment switches, emergency stop switch, etc. This is just a shot of the equipment. You can see that the grit collection equipment here, the grit washer discharging onto the belt conveyor, which then carries it off to the roll-off container. Self-leveling roll-off container, operation's the same as the screenings. In fact, the containers are interchangeable. There's 3 been provided for the east facility and 3 provided for the west. So that you can pull out an empty container, pull out a full container, replace it with an empty container, and just make that exchange that way. Downstream, once the flow leaves the grit chamber, you've got the number 1 and number 2 grit chambers here, shown on the drawing, and those are physically located here. Once the flow is discharged into the effluent channel, it flows down through a common channel. The flow here is coming in from the west grit facility, and there was a motorized gate here, which will be put into operation through SCADA and/or manually during a high flow condition. So that once you exceed the capacity of the east side, namely 80 MGD, the west side will be put into operation. The combined flow from the 2 buildings will flow here down through the channel toward the partial flume and onto the primary settlement tanks. Partial flume itself has got a 12-foot throat width. Some data on the flume itself. The minimum expected flow is about 24 MGD. The average flow is about 45, which is what you're running at right now. And the expected maximum flow through that flume with both facilities online is about 160 MGD. This is just a shot of the flume itself. The drawing on the right-hand side indicates where the flow measuring devices are. Flow and level measuring devices is one located on the upstream side, one located on the downstream side, and it gives you some elevations of the flume itself. At the flume, there's an automatic sampler, which is set up to receive a flow signal from the flume itself to get a flow proportion sample. There's a control pad. I believe this is identical to the system that we are running right now. The sampling chamber is located on the left-hand side of the control pad here. There's a heater within the unit itself, within the enclosure itself, in order to maintain the electronics in a dry condition and keep the samples from freezing. And below the sampler mechanism itself is the refrigerator for maintaining the sample. Sampler, as I indicated, it's a 4 to 20 milliamp signal coming into it for a flow proportion sample. As far as safety within the building, there are hydrogen sulfide gas monitors and explosive gas monitors throughout. There's 3 of each one of them inside the building. There are 2 of each on the outside of the building, which will be monitoring the airspace below the covers in the aerated grit chambers. Those are not online. We don't expect to bring those online right now because of the fact that the covers are not in place. But all of the ones within the building are up and running right now. So if you do get either an explosive gas condition or hydrogen sulfide buildup from bringing wastewater through the facility, that we will be notified on that. There's heat detectors and smoke detectors throughout the building. I'll point some of those out as we go through. HVAC control has not, I believe at this point, has not been set up as of yet. That monitors or controls your fresh air intake as well as your space heaters. There are some portable space heaters that will be brought into use during the startup of the operation. I mentioned the odorless air removal from within the building as well as from the covered tanks around the East Grit facility. There's an emergency lighting system. I'll point that out as we go through. For the septic receiving facility, there's a closed circuit TV, so you can tell, you can see who's coming into the facility. And there's also the vehicle detection system within the septic facility. Within the motor control center room itself, there's the individual equipment breakers for each one of the pieces of equipment in the building. Lighting and power panels. There's a bar screen control panel, the screenings wash control panel. We'll take a look at all of that. Fire alarm panel, lower VFDs, and the other control panels. There is also an operator interface terminal within that building, so that you can view what's going on with the process. From that point, if you have to respond to an alarm, that's one place you can go to get that information. Any questions at this point? Cut and dry? Okay. We take about 5 minutes and we'll meet out at the East Grid facility on the north side of the building toward the junction box. We'll stop. Here at the East Grid facility, I'm going to spend some time talking about what we just viewed in the classroom as well. The junction box is located across the driveway here. At this point in time, the control sluice gate has not been installed as of yet. Once we bring the East Grid system online, there'll be a bulkhead placed around that pipeline that feeds over to the West Grid facility in order to install that sluice gate. So the main flow is coming into the facility at the junction box across the driveway. From there, the 84-inch line feeds under the driveway and enters the facility right here. On the outside of the facility, as we talked about, there are septic receiving stations directly off to my right, behind you. There's card readers associated with that operation, as well as the coils within the pavement itself. So once a truck is in the stall itself and a card reader has been card has been flashed in front of the card reader and identified as a vendor that you will accept at the facility, then in the automatic mode, the receiving valve will open so that the vendor can then dump the material that he has on the truck. Off to the left here is the Vactor receiving station. There are a set of three slide gates so that they can discharge directly into the chamber below us, and this feeds into the operation. Directly below the plates here are a set of stop logs so you can isolate the channels in the building itself, or isolate the channels depending on which one you're running, as well as the motorized slide gate, which will direct the flow to either one or both of the channels. The controls for the slide gates are located right here, so you can run them either in the field or you can run them through SCADA, depending on how you select the control positions. Any questions at this point as to how we get the flow into the facility? Okay, let's take a walk inside. One thing I want to mention before I go in is the emergency generator is located off to my left. That's providing standby power. If in the event that you lose utility power to the system, the standby generator will sense the loss of power. The transfer gear is located within the electrical room. We'll take a walk by that on the way through. That will provide emergency power, or standby power to your facility to be able to run your operation if in fact you lose utility power. I believe right now that that's been set up for automatic operations, so that if we have a power failure at this point, the generator will come on and provide power to the facility. Okay? Let's take a walk in. Okay, as the wastewater comes into the building, there are a couple of bar screens here. The flow enters through either one of the channels. There is a flow measuring device that's looking at the water level on the upstream side of the bar screens. There's one upstream as well as downstream. The flow measuring device is located here in the center of the channel. That's looking at the water level, so that when your system is running in automatic, if it sees a high differential pressure, namely the high differential level, namely the bar screen has become plugged with material and the water has started to back up in the channel and back up into the interceptor system, that high level will trigger the screen to come online. Other than that, the screen would normally be set for timed operation. I've set that up right now to mimic what you're running in the west side, namely 5 minutes on, 10 minutes off. And because of the difference in the spacing between the bars, we may have to adjust that when we bring the process online, because the spacing on these bars is a little bit closer than what you have in the west facility.
What is the time on off that you have to set?
Right now it's set for 5 on and 10 off. Yes. And then in association with the level, there's another probe here, which is a ultrasonic gap switch, which is just a high level alarm. So if in fact you are running an automatic, you do get a high level, the screen comes on, and the water continues to rise. If you only have one channel online, you may have to bring another channel online. The alarm switch will give you an indication that your water level has come up higher than you normally would see it. Again, the level through here is normally 8 foot 4 inches when it's running at 40 MGD for each one of the channels. Okay. Any questions on that at all? Okay. You can't hear what I'm saying?
Yeah, I can now.
Okay.
I think I might have lost that though. That's why I must have missed.
Okay.
Maybe it was just a break in.
Okay, as far as the operation of the bar screen, there's a handoff auto switch located directly at the screen itself. If you're running the equipment locally in the hand position, placing this to hand will bring the screen online. If you go to automatic, then that will transfer control of the screen to the panel, which is in the next room. We'll take a look at that as we walk through. There's a park switch on the device itself, such that when the system shuts down under normal conditions, there is a single rake with a tab on it. Okay, thank you. There's a single rake with a tab on it that will trip the park switch, which is located on the top part of the machine, so that when the system shuts down, the rakes will be set so that they're equally spaced out of the line of flow.
I have a question.
Yes.
When we come in here and inspect the equipment, we put it in and make sure it's operating correctly. We go to put that back in auto. We have to go back to SCADA and also put it back in auto. In other words, like at the primaries, if we manually run the scum cross, you have to go back to SCADA and put it back in automatic to run its cycle.
I'm not 100% sure. I believe it'll still pick up an automatic. When you change this switch back to automatic, that then transfers control to the control panel inside. So long as that is in automatic.
Okay.
I
Well,
bel-
that's what I'm saying. When you put it in manual, it will switch out at the primaries. It will switch out from automatic to manual. Then you have to physically go back into SCADA and put it back in the automatic.
See, in this case, where you're running this in hand locally, you're not affecting the control at the control panel itself. That still remains in automatic.
But-
And I guess I don't have an answer to your question.
We'll have to just wait and see. Okay. 'Cause
Yeah,
it's
we-
different at the primaries.
We'll try that out during startup.
Just at the scum trust, right?
Yeah. Yeah, in this case, because there's a control panel between this switch and SCADA, I believe it will stay in automatic once you go back to automatic. And we'll prove that out when we go through startup. Okay? Okay, on the downstream, excuse me, on the downstream side of the screens within the channel, there's also a level measuring device located directly below this plate in the floor, similar to what you saw on the upstream side. Those readings are read out here. They're currently marked with a piece of duct tape with an instrument number on it. They will be tagged so you can identify which one is which. That's looking at the the level of the water within the channel itself. Again, monitoring for your high-level differential across the screen in order to bring the screen on if needed. Downstream of within the channel itself, there's a stop log, so you can isolate the channel below that, the next plate in the floor. From there, the flows combine into a common channel that feeds into the grit removal system, the aerated grit chambers. From here, the screenings are discharged onto the conveyor system. The conveyor belt itself is operated from this end of the room. You've got a handoff auto switch for the operation of the conveyor. You've got an emergency stop switch here. There's also an emergency stop switch which is tied to the orange cable that runs around the outside of the conveyor itself. Under normal conditions, the way the programming is set up right now, the conveyor will be online. That is interlocked to the equipment downstream, which is the screenings wash press. So the downstream equipment needs to be started first. So when you go to start this equipment up, we're going to start at the roll-off container and work our way back through to the conveyor system itself. When the conveyor is brought online, there's a couple things. There's a spray mechanism that is a solenoid valve on the spray line that discharges water onto the trough below the belt in order to clean the trough off, keep the material from caking up. And there's also an alarm system which will indicate that the conveyor is about to start. You've got an amber flashing lamp as well as a klaxon that will go off when you start the conveyor. So it gives you a kind of a warning that a piece of equipment is coming into operation. If you're doing maintenance on it or if you're working anywhere around the equipment, it gives you that little bit of warning because there are so many exposed moving parts on the conveyor system itself. These two conveyors, both for the screenings and the grit, will follow that same process because of the exposed pieces of equipment, exposed parts within the piece of equipment. The other equipment, namely the wash press, the screw conveyor, etc., do not have such warnings because everything is pretty much enclosed. It's difficult to even be in contact with that equipment. One thing I should mention is that if you are ever servicing a piece of equipment, you've got to remember that you should be locking out and tagging out a piece of equipment so that it cannot be started unless you are aware of the fact that it is being started. Okay. The alignment switches on the conveyor itself are located up here. There's a switch on either side so that belt tends to ride to the left or to the right. It will give you, it'll give you an indication of that. On the downstream end, the pulley at the lower end of the conveyor, there's a 0-speed switch. The drive on this system is belt driven, so that if you bring the conveyor system online and you lose a belt, or for some reason the conveyor belt itself is not turning, the 0-speed switch will shut the mechanism down and give you an alarm indicating that the belt is not running. So you will be able to monitor what's happening with that operation. From here, the screenings are discharged into the wash press, which is basically a grinder operation, followed by a washing mechanism where the organics are intended to be washed out of the material. There's an auger system within the lower chamber. There's a spray water line that comes on both for the grinder as well as the washing chamber itself, so that as the auger runs in the forward and reverse direction, and that's been set up on a time sequence, namely I believe it's 30 seconds in the forward direction with an 8-second stop and then 25 seconds in the reverse direction. What that's doing is actually applying water to the screenings as it's being discharged and washing the material to drop the, try to wash the organic material out of the screenings. The wash water itself is drained off the bottom of the unit and drained back into the inlet channel for further processing. From here, the auger pushes the screenings up through the discharge chute, up into the screw conveyor. Again, we would be starting the equipment downstream first, so that the screw conveyor can then accept the material coming from the screenings, the wash press. This will take some time when we go through startup to see a discharge from this because of the compaction of the material as it's run through the press. The screw conveyor then carries the material off to the roll-off container. We'll take a walk through there. Any questions on this operation at all?
Yeah, just like I said before.
Yes, it is. Yeah, there's an emergency stop switch around each one of the conveyors, including the screw conveyor here. It's a matter of just, if you lean against it, Steve, I'm watching, I'm going to pull the switch behind you. That will shut down the operation. In order to reset the switch in this case, you need to push on the switch and reset it that way. It's set up for the easiest pull. By changing the position of the cable on the trip mechanism, you can increase the tension that's required. Right now it's set for the easiest operation, so if someone leans against it, it'll shut the mechanism down. What's that? There is that potential, yes. And then in that case, you'd get a signal that your equipment is not running. Okay? Same thing on the screw conveyor. There is a safety switch on that as well. In that case, because there are no exposed moving parts, it's not as critical, but it does give you the capability of shutting that screw down in an emergency situation.